The focus of this video is an application of EOQ models where we have multiple items that we order. So in a single item EOQ model, we use the EOQ formula to find the best order size and then compute the total annual cost or total relevant cost and so on. But if we have multiple items that we order, then what's the strategy that we could do? So one option we have is we could order them separately. So say we have item A, item B that we order, and we want to order item A separately and item B separately. Another scenario is that we could order these jointly. So we could say, okay, item A and item B are going to be ordered jointly, and we are going to receive them together. So we are going to compare these two strategies. So in our example, assume that we are operating coffee shops at our PI campus, and we purchase two types of ground coffee from a local producer. One, regular ground coffee, and two, pumpkin spice coffee. And these coffee types are sold in boxes. Therefore, we pay for a box of ground coffee. So in a box, we have multiple packages, but we pay for box of these packages. And the annual demand for regular coffee is 10,000 boxes. And for pumpkin spice coffee, the annual demand is 4,500 boxes. So one assumption for EOQ models is that the demand is not variable. So there is no seasonality in the demand. So we know that the annual demand is 10,000. It's a constant value. So another assumption of EOQ model is that we pay fixed item cost. But in this case, we pay a fixed order cost of $100 per order. And in addition, we pay $25 for regular coffee and $20 for pumpkin spice coffee for receiving and storage. So there are basically two types of fixed order cost, and one is a general cost of $100, and there is also a fixed cost which is specific to these coffee types. And each ground coffee type costs $30. So per box, we pay $30 basically, and the holding cost is 25% of the unit cost. So if we go back to the assumptions of EOQ, we said the demand is not variable. The item cost is fixed, ordering cost and inventory holding cost are fixed as well. And the lead time is constant in this case. So what this means is we order and then we receive this item, and the time between this ordering and receiving the item is constant all the time. So these are the basic assumptions of EOQ models. So if we go back to our problem, we want to find the optimal order size if we order them separately. Another case, what if we order them jointly? And then we are going to compute total relevant cost for each of these cases. And let's get started. So in terms of parameters, we have this annual demand, D. S is fixed cost that we pay when we place an order, and C is cost per unit, and H is inventory holding cost as a fraction of C. So going back to our problem statement, so annual demand is going to be composed of two types. One is DR, which is the demand for regular coffee. And we know from problem statement that the demand for regular coffee is 10,000 boxes. For pumpkin spice, we are going to represent it by D sub P, and the demand is 4,500 boxes. In terms of fixed cost, similar to a single item EOQ model, we have S, which is $100 per order. But in addition, fixed cost for specific items exist. So we are going to say SR is the fixed cost for regular coffee, $25, and SP is $20. So the fixed cost that we pay in addition to the general fixed costs for both of these coffee types. And each ground coffee costs us $30. So C is the same for all coffee types, and we pay $30 per box. And the holding cost is 0.25. So given these values, now we can use the EOQ formula and find our best order size. So now we can go ahead and use the EOQ formula to determine the optimal order size for each coffee type. And this is for the case where we order them separately. So part A, we have, let's call it QR star, and the formula of EOQ is 2DS divided by HC. And demand for regular coffee is 10,000 boxes. S is 100, but we also pay $25 for regular coffee in addition to the $100 fixed cost. So the total fixed cost is basically $125 for regular coffee. And H is 0.25, C is 30, and the result of this is 577.35 boxes. So if we order them separately, for regular coffee, we need to order 577.35 boxes. How about pumpkin spice? Let's call it QP star. So the formula is the same. The values are different. So demand is 4,500 boxes. Fixed cost is 100 plus 20 this time. And inventory cost is given, and this value is 379.47 boxes. How about the cost? So we also want to find the cost of these orders. So this basically corresponds to part C. So let's compute the total cost. So TC is going to represent the total cost of these orders. So let TCR represent the total cost for regular coffee. So based on the total cost computation, DR divided by QR times S plus QR divided by 2 HCR. So this is our total relevant cost. So demand is 10,000 for regular coffee divided by 577.35 times order fixed cost 125 plus order size is 577.35 divided by 2, and H is 25, C is 30. So based on this, the value I found is roughly $4,330. So similar approach for pumpkin spice, I'm gonna leave it to you. You should be able to find something around $2,846. So the total cost for these orders is basically total relevant cost is the sum of these individual cost values, and that is equal to 7,176. So the other case is the case where we order them jointly. So if we order them jointly, we need to find a combined order cost. And the way you find this represented by S star, and you basically sum all of these fixed cost values. S plus SR plus SP. S is 100, SR is 25, its P is 20. So that is $145. And we first find the annual order cost. So annual order cost is computed by the order cost, which is S star in this case, and the order frequency. So order frequency is going to be represented by N star. So this is order frequency. So this represents how many times we place an order. So therefore ordering cost is S star times N. Annual holding cost is computed by this formula. So from EOQ formulation, we know that annual cost is Q divided by 2 times H times C. Q divided by 2 is our average inventory, because your starting inventory is Q and you end up with 0 inventory. Therefore, your average inventory is Q over 2. And your inventory cost is computed by H times C, because your H is based on your unit cost and C is your unit cost. Therefore, if we compute the order frequency, which is, so order frequency, let's compute it here, N is computed by D divided by Q. So your demand is D, your order size is Q. This tells you you place D over Q orders. And therefore, if we replace Q by D divided by N, we end up with DHC divided by 2N. So therefore, we are going to use this to compute our holding cost. And since we have two items, we are going to say DRHC divided by 2N, DPHC divided by 2N. So this is going to be our total holding cost. Therefore, our total relevant cost is going to be S star N plus DRHC divided by 2N, DPHC divided by 2N. So to find the best N value, the order frequency, we can take the first derivative of this cost with respect to N. And if we set that value equal to 0, then we are going to find the best N value. Therefore, if we use this method, we are going to find N as this: dr times HCR plus dP times H times CP divided by 2S star. So if we plug in the values, so N star, so dr is 10,000, H is 0.25, CR is 30, dP is 4,500 times 0.25 times 30, and 2 times S star is 145, and basically the solution to this is going to be 19.36 orders. So this 19.36 is basically our number of orders that we place. So using this value, we could compute the order size for each item. So the formula is, say QR is the order size for regular coffee, and that is found by demand for regular coffee divided by N star. And demand is 10,000 for regular coffee, and N is 19.36, and this value is equal to 516.5 boxes. For pumpkin spice, demand divided by N star. Demand is 4,500 this time, 19.36, and this value is equal to 232.4 boxes. So you could also find the total of these values. So you could just sum dr and dp and divide it by n star, and that is going to be the total order size. So individually we found QR and QP, but if you want to find the total Q, then you're just going to sum QR and QP, and it's going to be the order size as well. So the last thing is the cost associated with these orders, and we are going to use the formula here and basically just plug in the values. So S star is 145, N is 1936, plus DR is 10,000, 0.2530 divided by 2 times 19.36, plus 4,500, 0.2530 divided by 2 times 19.36, and this value is equal to $5,615.7. So this is the value we find by using this joint scenario. How about the independent case? So in independent case, if we order these independently, separately, the amount of money we pay is $7,176. But if we order them jointly, then this value is reduced to 5,615. So there is a big difference, around 1,500, and this shows us, for this particular case, for this example, ordering these items jointly saves us money. And this ends this video. Thanks for watching.